Hello, I hope you are getting used to a new learning environment, online class. Over the weekend, I graded your midterm and quiz number 5. It's quite late, but I posted your score on Moodle. Check your score, and then if you want to see your um, midterm or quiz number 5, where you miss score, then email me and make an appointment. Then I will send you an WebEx invitation, and you can see me. You come to my office on a regular base. That it's the same as my office hour, Monday and Wednesday, between 2:30 and 4. You can see me. So if you need to see me to discuss your midterm and quiz number 5. By the way, as I promised earlier, one of the lowest quiz score quiz based on your midterm answers and score, I adjusted your lowest quiz scores, one of, and some most of you your scores adjusted, but some students score lower than the midterm question score lower than quiz question score. So some students uh, didn't take that opportunity. Okay, today's chapter is now 15, scheduling. Scheduling is assigning specific tasks, jobs, and work for equipment, facilities, and human resources in accordance with a timed planning horizon. Once we have a production plan, like an 1,000 uh, product next month, next week, like that, then make it detail instruction, like converting the production plan into day to day or week to week, uh, to assign to workers, equipment, and so on. That is the scheduling. Objectives of scheduling. Meet due date. If we have a due date like 10 days later, then the job need 5 days, then we should start 5 days earlier than due date. And lead time. Lead time is time between order and receive. So by scheduling well, we can reduce or minimize lead time and setup time or cost too. We can minimize work in process inventory by scheduling, and also maximize machine utilization. So by better or scheduling, we can improve machine utilization. Capacity and scheduling, infinite loading and finite loading. If we have capacity here, then disregard capacity, just schedule. sometimes lower than, sometimes higher than, doesn't matter, just a schedule. Finite loading is about the capacity, always lower or meet the match the capacity, that is finite loading. Forward scheduling and backward scheduling method. Forward scheduling each operation when system takes an order. Don't work until take an order. The system is make to order system. When demand is unknown, the process doesn't work. But then after taking order, then start process, that is make to order system. Usually make to order system use forward scheduling. I will show you how forward scheduling work. I will use if there are multiple works, it doesn't go. And then here customer side, and then supplier side. When receive customer's order, then this process, okay, this is a system, doesn't have this one doesn't have a part, so ask part to upper stream work or job or work like this. Ask part. Then I will change color. Supplier said 5 days later I will send you part. Then 5 days later this one part comes. Then this one knows when part comes, so this one schedule. And then this one knows like 2 days work. Then this one knows when part comes. And this one knows when part comes, and this one knows part comes. So schedule this one first, next, and next. From upstream to downstream, same direction. So from upstream to downstream, 1, 2, 3, 4, the scheduling order. So same direction as like a water flow from upstream to downstream. So we call this forward scheduling. Okay. Delete this one. It's not convenient. Oops. I will delete all. Okay, next one is backward scheduling. Production activities are scheduled by their due date. We didn't cover yet about the MRP system. Demand is unknown, and then take on order, then start, that is make to order system. MRP system is conventional system, traditional system, that is make to stock system. So make to stock system produced by forecasting, that means by due date. So make to stock system use backward scheduling. I will draw the process again. Oops. Okay, again, multiple works in a system, and then customer side and supplier side. So make the stock system knows due date. So due date knows due date. We know due date. Like this one like taken 5 days. Then this one started at least 5 days earlier than the due date. So schedule this one first. And then schedule this one, schedule this one, and schedule this one. And again, this one upstream to downstream. And then the order of scheduling is backward of this upstream downstream. So we call this backward scheduling. So MRP system or traditional system, back to stock system, use backward scheduling. Delete all. And next slide. Resource and scheduling, motion limited process and labor limited process. Based on machine hour, available machine hour, or based on labor hour, like earlier we talked about infinite and finite. Regarding machine hour, available machine hour, and labor hour schedule, that is regarding resource and scheduling. Job sequencing, the process of determining which job to start first on some machine or in some work center. If there are multiple works, then we assign which one first, which one next, and so on. That is job sequencing. Many priority rules, FCFS, first come, first serve. You know this one. We use this one many cases. If we go somewhere, then whoever come first, then give service or product, and so on. And SOT rule, shortest operating time. Run the job with the shortest completion time first. Among works, multiple works, shortest operating time. Job first and next and so on. That is the shortest operating time rule. And STR rule, select time remaining. Select time means time remaining until the due date, and then select time remaining minus remaining process time. If we have 10 days until due date, if the job needs 5 days, 10 minus 5, then 5 days is 10 minus 5, that is select time remaining. So shortest and select time remaining first and second and so on. STR divided by operation, that is select time remain per operation. Select time divided by the number of remaining operations. This time, this like ratio, lower, shortest, first and second, and so on. And due date rule, run the due date job, shorter due date first and remaining time, and so on. Critical ratio rule. Critical ratio means due date minus current date, that is remaining days divided by the number of works. So using this ratio, smallest first and second and so on. Late come first served. Seldomly use this rule, but there is anyway. And then random among multiple works, take randomly and next one random choose and so on. That is random order or Vim rule. Example, if there are 5 jobs, and then they come first A, B, C, D, E, and each job need 3 days. This is operation time: 3 days, 4 days, 2 days, 6 days, and 1 day. And due date 5 days later, 6 days later, 7 days later, and so on like that. And then if we use FCFS rule, first come first serve rule, then A come, B come, C come by order, then take A first, B, C, D, and so on. Then total time, flow time will be 3 days. It will 3 days. Then this one wait, job B wait. So 3 days plus 4. So flow time is 7. Then 3, 4, 2, 7 days wait, and then 2 days work. So total flow time for this job is 9, and so on. So add all flow times, then 50 days is total flow time of to finish all jobs. Then mean flow time, total flow time divided by the number of jobs, 5 equals 10 days. On-time job, it takes 3 days, and due date is 5 days later, so meet the due date. Due date is 6, but 1 day late, 2 days late, 6 days late, 14 days late, because 16 minus 2, 14 days late. So only job A meet the due date, and then other jobs late. And average lateness, this one meet due date, so lateness is 0. 1 day late, 2 days late, 15 minus 9, 6 days late, 14 days late, and divided by 5. So on average, 4.6 days late if we use the FCFS rule. And then if we use SOT rule, shortest operation time rule, among jobs, job E, 1 day processing time or operation time. So take this one first, and second, third, and so on. Based on the operation time or processing time. Then flow time, total flow time will be 13610, 13610, 16, so 36 total flow time. And mean flow time divided by 5 equals 7.2. On meet the due date, E and C meet the due date, and others 1 day late, 4 days late, 7 days late. So E and C meet the due date, late A, B, D, and average lateness 2.4. Excuse me. And due date rule, whichever due date, shorter due date first, then second, and so on. So job sequence is E, A, B, C, D. So total flow time 39, mean flow time 7.8, on time job, meet the due date E and A, others are late. Average lateness 2.4. Next rule, if we use LCFS, then A first but last, E last but first, so EDCBA job sequence. Then total flow time 46, mean flow time 9.2, on time E and D, late jobs CBA, and average lateness 4.0. And random rule, randomly take. So this one, this sequence can be different anytime, every time. Total flow time 53, mean flow time 10.6. On time A, late B, C, D, E, and average lateness 5.4. And STL rule, using select time rule, select time. This one, processing time is 1, due date is 2, so difference is 1, difference is 2, difference is 2, difference is 3, difference is 5. So based on select time sequence E, A, B, D, C, and 43 total flow time, 8.6 mean flow time, E and A on time, late job, BDC, average lateness 3.2 days. Compare those rules. Then SOT rule, total flow time, shortest, and of course mean flow time, shortest, and average lateness shortest, and tie with the due date rule. In real world, usually we use this first come first serve or due date. If we use if we apply this shortest rule in real world, this one always true. Always shortest total flow time, mean flow time, shortest average lateness. So in real world, if we can use this, then always we can save time. Next one is scheduling n jobs on two machines. N jobs on two machines. When I work at other university, then they have a better copy machine. When I make a copy, then select how many and such option. Then make copy. Then the machine automatically staple. But at Marywood University, we have a kind of old copy machine. Just make a copy, not there is no staple function. So when I make a copy for a lecture note, after make a copy and then I staple manually. It's like that. Make a copy and then staple. Two operations. Certain job need two operations like this. That is our copy machine making a copy job is an example of a job, and jobs need two machine, two works. And another example is now when we do laundry, wash and dry. So if we have the washer and dryer, then first wash it, wait until it finish, then move that cloth, whatever laundry to dryer. So two machines we need. Using the dryer kind of machine, but sometimes we use hang dry under the sun, breeze. Yeah, still many people use this kind of hang dry. Yeah, because many people believe hang dry under the sun and then breeze is better than motion dry. Anyway, if we have multiple jobs and jobs, and then those jobs need two machine works, then we use Johnson's rule to minimize flow time. First step, list operation time each job on the both machine. Job A need 3 time units, and on machine 1, 2 time units. On machine 2, B need 6, 8, C need 5, 6, and so on. Then, step 2, select shortest operation time among operation times shortest, this one. Take this one. And then, if the shortest time is for the first machine, do the job first. If it is for the second machine, do the job last. From this example, this shortest time among operation times, this one for the second machine, so do the job last, and so on. Okay, and then repeat step 2 and step 3. Okay, so this moment. Okay, I will use pen. Okay, this one is shortest among operation times. So job A, job A, job A to the last, because this one is for the second machine. So job A placed last, and then second shortest, because job A is assigned, so Oops, why it doesn't work? Well, oops, why it doesn't work? Okay. So job A cross out, and among remaining 4 is the shortest, so that one is job D is second machine, because this one is second machine, second last. So place job D second last, and then why it doesn't work well. Gee. So anyway, job D is cross out, and then among remaining operation times 6, 5, 8, 6. 5 is second next shortest. So job C this time is for the first machine. So job C goes first, and then next one is B 6, 8 first machine. So job B second first. So job sequence is C, B, D, A using Johnson's rule. So job C goes machine 1 first, then B wait. After job C finish, move to machine 2, job B, machine 1, and so on. So total flow time is 25. Okay, we have this moment practice problem. I will change screen. Okay, here there are 7 jobs, and operation A, operation or process B, time, 2 machine, and multiple jobs. So we use Johnson's rule. So among process times or operation time, this one is the smallest. So job 5 goes first, because this operation time for the first machine. So here job 5, then cross out, and then this one is shortest, and first machine job 6 goes second first, and cross out, and next shortest time is this one, second machine. So job 4 goes last. cross out. And this one is next shortest. First machine, so job 7 goes third first and cross out. And among them, this one is next shortest. Second machine, so job 2 goes second last and cross out. And next one is this one, so job 1 goes third last and cross out. And job 3 goes here. So job sequence is 5, 6, 7, 3, 1, 2, 4. Okay. That's all for today's lecture. You have assignment 3. Assignment 3, click this one, go back. Oh, you have assignment 3. Click this one. Then there are 5 true or false type questions. And due date is by next Sunday. And 2 attempts are allowed. And then each attempt 15-minute time limit. Click maybe different. Maybe this button for you is start quiz now. Okay, because there are 2 attempts allowed, take first, and you may see your score. If you don't like, then you can take one more. Okay, that's all, and see you Wednesday again. Bye.